Hello ladies and gents, this is Daniel for Rock the JVM, and in this long-form video I'm going to demonstrate a bunch of techniques with Akka integrated with Cassandra and a few other bits in the Scala ecosystem. So here I'm going to demonstrate a mini project with Akka Typed, Akka Persistence, Akka HTTP, Cassandra as a persistent storage, and some cats for data validation. So this will require some basics of Akka and cats, which we teach here at Rock the JVM and in a bunch of other places here on the Rock the JVM channel and blog, and also Docker installed on your computer. I'm going to show you what you need to do step by step. And as recommendations, I will ask you to code with me because there's no better way to learn these techniques than to try them on your own. You can also find a written form of this video at the Rock the JVM blog with the link in the description. Alright, so in this video, we are going to demonstrate a so-called mini bank application where we are going to update people's bank accounts, create them, destroy them, update their balances, and so on and so forth. So we will need to design this bank application in terms of actors, Akka HTTP for a server, and Cassandra as a storage system. So each bank account for every person will be a persistent actor that will store all the relevant events of that bank account to Cassandra. So we will use event sourcing for this application. So all the events are recorded to Cassandra and they're replayed in case one of the actor dies or the entire application needs to be restarted. We will also have one bigger actor that will be the bank itself that will manage all of the accounts. And we will interact with this entire system through an HTTP REST API. So we will start an Akka HTTP server that we will use to interact with a bank account and therefore with every single account underneath. And all of these events will be stored in Cassandra for long-term storage and also for event sourcing in case we need to replay those events in the case of failure. Now, in terms of the HTTP REST API, the application that we are going to write in this video will have a pretty simple HTTP API. We'll have a post at the root location, which will create a bank account, a get at a UUID, which is the unique identifier of a bank account to retrieve the current details of that bank account, and an update in the form of an HTTP put. And you can find the relevant responses in the table below. Now, you don't need to memorize them because I'm going to show you step by step what we need to do. So without further ado, I'm going to go back to my little project here that I've created in IntelliJ IDEA. This is a plain Scala project, and I've added here under build.sbt, I've added all the relevant libraries that we are going to need for this video, and I'm going to have them ready for you in the blog post. So you can check out the link in the description and paste the build.sbt and add it here to your own project if you want to add the entire set of libraries. And after you add them, you can go to View and then Tool Windows and then SBT. And if IntelliJ does not download all the libraries for you automatically, you can click this refresh button to force IntelliJ to download them. Cool, so if you need to pause the video, go ahead and pause it and add your build.sbt to your own project. And besides that, I'm going to add another file that I'm going to call docker-compose.yml. For those of you who know Docker, you know what this is. Docker-compose.yml is the specification of Docker services that we are going to use in this video, and we're going to use Cassandra here. So in this Docker Compose file, I'm going to add the version, which is 3.8, the latest at the moment of this recording, and we're going to add a bunch of services, and we're going to add Cassandra. And I'm going to use the image as Cassandra, and the version is 403. And I'm going to expose some ports, and the port that I'm going to open is 9042, the classical one for Cassandra, so that we can add or we can interact with Cassandra on CQL. And for environment, I'm going to use the configuration Cassandra cluster name equals, and I'm going to give it a name. Let's call this Akka-Cassandra cluster or something like that. So this is the entire Docker Compose YML that we're going to need in this video. After you add this Docker Compose file, you can open a terminal window, assuming you have Docker installed on your computer already. So I have here a terminal window. I've navigated to the project that I'm writing here from scratch, and I'm going to hit this command docker-compose up to spin up the Cassandra Docker container. So hit this one. Now, the first time you run this will probably take a few minutes to pull the image. I already have one on my computer, so if this takes a little longer, don't fret. Just pause the video until this thing is done, or you can simply carry on and get back to the code while the Docker container is running. And after the log stops pushing some output, you can open another terminal window and you can do docker ps to understand what kind of Docker containers you have already. I have Akka Cassandra bank Cassandra _1. This is the name of my Docker container, and I'm going to use docker exec-it, this thing, and then cqlsh, the Cassandra query language shell. And here we have cqlsh. If the Cassandra Docker container spawn up correctly, then you should see this new prompt here, which we won't need to use at the moment because we don't have any tables. Once Akka Actors start writing to the Cassandra table, we will have some tables to inspect, but right now we are good to go with the Cassandra Docker container. So if you need more time, just pause the video until the Docker container has finished downloading and setting up. Run this command, docker exec-it, and then use this name, Akka Cassandra bank _Cassandra1. This is quite a mouthful. And cqlsh, the SQL shell, and you should be able to obtain this prompt. After you've done that, you can come back to the code because we're going to start actually implementing some of our actors. So under our project, we have source main Scala here. Obviously, we don't have any code, and I'm going to create a new package. I'm going to use com.rockthejvm, and I'm going to use actors here as our first package. And under the actors package, I'm going to create my first Scala class. I'm going to call this persistent bank account. So leave it a class for now. We're going to modify the code as we go along. So this persistent bank account is at the bottom of the hierarchy. This will denote a single bank account. So this single bank account will receive some messages and will store some events to Cassandra. This is the event sourcing approach to storing data. So the long story short with event sourcing, if you haven't heard this before, unlike traditional databases where we store the latest state of the data in the database, in event sourcing, we store events, that is bits of the data, which comprise the journey to the latest state of the data at this moment. So we obtain the latest state of the application by replaying all these events one by one. Now, this event sourcing technique, although a little bit more costly, is also much more powerful and much richer in information for a variety of reasons. For instance, for event sourcing in the case of fault tolerance, that is, in the case that the application fails for some reason, if it crashes or if an actor dies or if the server goes down, you'll have the entire journey to the latest state of the application written in your database. So it's no biggie to simply replay all these events and get back to the same state. That is one. Also, in the case of a bank account, it's much more important to be able to audit the entire journey of the bank account. So auditing purpose. And if you get a suspicious transaction that you didn't notice at some point in the past, you can always revisit that and figure out if something went wrong at that time and do something about it, even though that transaction or the deposit or withdrawal or whatever occurred earlier in time. So fault tolerance and auditing are the two biggest reasons why we want to use event sourcing. And we're going to make this persistent bank account a persistent actor, which implements the event sourcing technique out of the box. Now, a persistent actor in Akka will need to handle a bunch of data structures. First, we need commands, which are the messages themselves. And you probably know of Akka Actors that they receive messages asynchronously. We need to store events to the database. So these are the data structures to persist to Cassandra. Then we have state, which is the internal state of this bank account, which is its own data structure, and also responses that we want to send back to whoever queries or wants to modify the bank account. So we will need to define some data structures to describe all of these. Now, for commands, I'm going to define a seal trade. I'm going to call this command, and I'm going to define a bunch of data structures that will signify a bunch of modifications to this bank account. So for example, I'm going to create a case class. I'm going to call this create bank account, and I'm going to have a user as a string and the currency as a string, the initial balance, and I'm going to use a double here, but with a caveat: do not use double for storing money in a real application. I'm going to describe shortly why. And a reply to actor that you will use to store a response. So I'm going to call this reply to as an actor ref. So I'm going to have an actor ref of, and the message type is going to be a response. I'm going to have a sealed trait. I'm going to call this response. And this response will be used in this actor ref that I'm going to communicate my status back to. So I'm going to have response here. Now, why did I say that the double type is not appropriate for money? Well, it's because the floating point standard, the IEEE 754, is inappropriate for storing arbitrary decimals, and that means tenths and hundredths, which are the two significant digits in which pretty much all money is stored. And this poses some trouble when you want to multiply with percentages, with other doubles, and even plain arithmetic can break some precision, which means that people's money can be added or subtracted for the simple lack of proper arithmetic on floating points, which can be a serious bug and can be exploited, which is the reason why we never use double for currency. We use other specialized data structures for money. Now, I'm not an expert on money, but I do understand the technical caveats to using double, so be very careful of using that. I'm going to then create a case class for an update, so an update balance. And I'm going to have an ID as a string. This is going to be the bank account in question, the identifier of the bank account. The currency as a string, if you want to do some currency exchanges, maybe. Then the amount, which is a double. And I'm continuing to use double here for ease of use because it's built into the language. And the reply to is another actor ref of response. And this amount can be positive or negative. So this update balance can both be a withdrawal or a deposit. So this can be negative. So it can be less than 0. Okay, then I'm going to have a case class. Let's call this get bank account. If somebody wants to obtain some details about this bank account, maybe people want to see their balance in their mobile application. So I'm going to have an ID as a string, the unique identifier of the bank account, and the reply to as an actor ref of a response. Okay, so these are the commands that I will implement. Now, the events themselves will be the data structures that I'm going to persist to Cassandra that will guarantee the fact that once replayed, I'm going to be able to obtain the latest state of my application. And the state is going to be a plain data structure. I'm going to call this case class. I'm going to call this bank account or state if you'd like. I'm going to create a string as an identifier of the bank account, the username as a string, maybe an internal representation of that, the currency as a string, and the balance, which is a double. Of course, never use double for money in production. We already talked about that. And the events are some data structures that will signify an action or something that happened to this bank account. So I'm going to create a trait called event. And I'm going to create a case class. I'm going to call this bank account created. And I'm going to store my bank account as a bank account data structure. So upon creation, I'm going to store this data structure into Cassandra, and this extends event. And by the way, I'm going to make all of these extend command, and this extends command, and this other one extends command as well. So all these extend command. This one extends event. And the bank account created is the first event, and I'm going to create another case class, and I'm going to call this balance updated as new balance as a double. And you can store either the new balance or the updated amount. And I think this is more interesting here. So I'm going to store the amount that was either added or removed from the bank account, and this extends event as well. Then we have the state of the bank account actor, and I'm going to have a response. Again, I'm going to define some case classes. I'm going to call this bank account created response that will have an ID, which is uniquely generated for this particular actor. So once the bank itself tries to create the bank account, I'm going to reply with a bank account created response with a newly created unique identifier. So this extends response. I'm going to create another case class, bank account balance updated response, and I'm going to store the new state of the bank account because I might be interested in the new balance at the bank site. So I don't really, I'm not really interested in recomputing the balance. So I'm going to have, let's call this maybe bank account as an option of bank account. And I'm using an option because if somebody tries to update balance on a bank account that's non-existent, then this option should be none. So I'm going to extend response. And finally, I'm going to create a case class. Let's call this get bank account response. And again, I'm going to have a maybe bank account as an option with bank account. So if somebody tries to obtain a bank account with an ID that does not exist in the hierarchy, I'm going to return none in this data structure. So this extends response. And we have all the data structures that we need. So we have commands, events, states, and responses. Now, I'm going to go ahead and create the persistent bank account actor. Now, a persistent actor is defined in terms of two things: a command handler and an event handler, plus a state. So every persistent actor will have a state, in which case, in our case, this will be a bank account data structure. And a command handler will be pretty much a message handler that upon the reception of a message, this will persist an event. And the event, after being persisted to the persistence store, in our case Cassandra, will be subject to this event handler, which will be usually to update state. And that updated state will be then used on the next command, on the next message that will be received by this persistent actor. So the mechanism is a little bit more complicated and the API is quite involved, but I'm going to walk you step by step. So first, I'm going to create a command handler. This is a function from state and a command message. So this, in our case, is a bank account. And the message is command. So upon the reception of a command, and with this current state of the persistent actor, we will produce what is called an effect. And the effect is going to be from this package, Akka Persistence typed Scala DSL, so make sure you import the right one. And effect has two type arguments, and I'm going to use the event trait and the state, which is bank account. And I'm going to keep it unimplemented for now. So the command handler is a function from the command that is the message that the actor has just received with the current state of the actor at this time. And this will produce an effect which has the type event and the same state, same bank account type. The other handler is going to be the event handler, which is also a function from a state, which is a bank account, and the event that's just been persisted, and the end result of that is going to be an updated state. So in this case, a new bank account. I'm going to keep this unimplemented for now. And I'm going to define an apply method that will take an ID as a string, and I'm going to uniquely generate this in the main bank account actor. And this is going to be a behavior, and the behavior is pretty much the message handler that is defined in the Akka Typed library. So I'm going to have a behavior of command. So this actor is described in terms of this behavior, which receives just these command messages. And obviously, the implementation of this behavior will take into account the command handler and event handler. But the main API of this actor is going to be just the behavior of command. And for Akka Persistence, I'm going to use event sourced behavior. And we'll need to have three type arguments. First of all, the message type command, the event type, and the state type, which is a bank account. So notice that we have message, event, and state. And we're going to pass a bunch of arguments here. We're going to use a persistence ID, which is a unique identifier by which we will identify messages or events of this actor in the persistence store. So I'm going to have persistence ID from Akka Persistence typed, so I'm going to use that, of unique ID, and I'm going to pass this ID as a string because this is a unique identifier generated in the main bank account. I'm going to use the empty state as a empty data structure, so I'm going to have to create a bank account with, we have an ID, which is a string. The ID, we're going to use the user as an empty string, the currency as an empty string, and the balance as 0.0. Now, this empty state will never be used because once this persistent actor is being created, we're going to store pretty much everything in a new data structure, so this will be unused, but it's important for Akka Persistence. Then I'm going to use the command handler as the command handler, and the event handler as the event handler function that I've just created. Now, let me go ahead and implement these two. So we have the command handler and the event handler. Okay, so this is a 2-argument function. Okay, so I'm going to use state and command, arrow, and I'm going to use a pattern match on this command. So I'm going to have command match, and I'm going to run a pattern match on the cases that I have here at the top. So in case I get a create bank account with a user, currency, what did I have there? Initial balance, and the reply to actor, I'm going to fetch my unique identifier. So I'm going to have val ID as state.id. So state is the bank account data structure, which has the unique identifier. All right. So I'm going to obtain that, and I'm going to create an effect which persists an event. So I'm going to use the following structure. I'm going to say effect.persist. And notice that we have a bunch of arguments here. So this is a builder pattern. I'm going to use persist, and I'm going to persist a single event, which is bank account created. This is the event. Now, the bank account created will have a data structure which contains the new state, which is a bank account. So I'm going to have bank account with ID, the unique identifier, the user, the currency, and the initial balance, because they're all contained in the create bank account message. And then I'm going to pass a message. So I'm going to say then reply. So I'm going to then reply to this reply to actor, which is going to be my main bank actor. So the bank actor will talk to me to create this bank account. And then I'm going to reply to it this response, the bank account created response. So I'm going to have a lambda which says bank account created response with that unique identifier. So the main bank actor will instantiate this persistent actor by calling apply, and then it will immediately send to me the create bank account message so that I initialize my state. All right. So the way that this is going to work is that the main bank account is going to spawn this persistent actor, and then it will send this create bank account message to me, the persistent bank account actor. And I'm going to persist this bank account created event into Cassandra. So this is persisted into Cassandra. And after it's being persisted, the event handler will take care to update my own state with the ID, user, currency, and initial balance. So this event will be used to update my own state. And after that happens, I'm going to reply back to the main bank account, to the main bank actor with this response that it can surface back to the HTTP server. So the stages are, first of all, bank creates me. Bank sends me create bank account. Now I persist this bank account created, then I update my state with this new bank account, and then I'm going to reply back to bank with the bank account created response. And finally, the bank surfaces the response from or to the HTTP server. Right, so this happens after that. This is not up to me. I'm going to implement this functionality a little bit later. Cool. So this is the sequence of operations. Now, let's handle the rest of the messages. So in case I get, what do we have here? An update balance. Okay, so we have an update balance. I don't really care about the ID and the currency because the bank is supposed to filter those out for me. I might do some extra checks here. So this is to do for you if you want to add some more functionality here or extra or more stringent checks. The amount is going to be a positive or a negative number, and then the reply to actor, so reply to. Now I'm going to obtain my new balance as state.balance plus the amount. Now I will have to check if the amount is negative and bigger in absolute value than the state balance. So this is going to have to be a check here for withdrawal. So I'm going to do an if, saying if new balance is less than 0, then this is illegal. And I will have to I'm going to return an effect.reply. And I'm going to use this reply to actor because this is going to be my main bank actor. And I'm going to reply with a bank account balance updated response with none. As I mentioned earlier, this bank account updated response is going to return an option with a bank account if the operation was successful, none otherwise. So I'm going to return a none. Now, you can create a different data structure here. Maybe you can use a try or some other data structure that might surface out the reason why the bank account updating failed. I'm going to simply use a none here. Now, I forget the API. The lambda here is only applicable to the effect.persist thing, so then reply, then you'll have the new state after the event was handled, and then you can use that state to inform the message that you will use. But in this case, with effect.reply, you don't have that. So I'm going to return the none here in the case the check failed. Otherwise, I'm going to use the effect.persist. And I'm going to persist the balance updated event here. So I'm going to have balance updated. Balance updated with new balance. Now you can use the amount or the new balance depending on how you like to model this. I've added the amount, so I'm going to pass the amount here. And then I'm going to say then reply to the reply to actor. And this will take a lambda that contains the existing state. I'm going to contain the new state here. And then I'm going to return bank account balance updated response with some new state, meaning that the update balance command worked successfully. And I'm going to update to the bank account. I'm going to return to the bank account this message containing some new state, and the bank actor will be able to handle that. So that was the update balance. And in case I get, what do we have here? We have get bank account. So I'm going to have get bank account with the ID and reply to. I'm going to return effect dot reply to the reply to actor, which is my bank account. And I'm going to have the get bank account response with some state, which is the state at the top of the function. So the bank actor, the main bank actor, will create this persistent bank account actor, and after it creates this bank account, it will send the create bank account message, which will initialize its state. And whenever the bank actor receives some commands, those commands will reach back to me. So the bank actor will forward those to me. So when I get an update balance, I'm going to reply back to the bank. I'm actually going to rename this to, say, bank here, because this is more descriptive, not just the reply to. This is pretty generic. I'm going to call this bank. All right, so this is the command handler for the messages that this persistent actor will receive. Now, let's talk about the event handler. I'm going to run a 2-argument function, which is state and event. Then I'm going to run a pattern match on the event, so event match. And there are 2 events that I can persist. I persist a bank account created and balance updated. So I'm going to have a case for each. So bank account created with a bank account. Then I'm going to update the state. So I'm going to return a new bank account, which is this exact one. So I'm going to return bank account. And in case I get balance updated with the amount, I'm going to return a new state copy. So I'm going to have to say state.copy, not currency, but copy, where the balance is equal to state.balance plus the amount. And that is my event handler. And at this point, the persistent bank account is pretty much complete. All right, so in this video, we wrote the bank account actor, which is a persistent actor. So thanks for following along so far. Keep the code handy because in the next video, we're going to write the bank itself, which will manage all of these bank accounts. So if you like the project so far, give me a thumbs up and subscribe. The next video is coming right up.